This is a little bonus video on testing for short circuits on a layout. So again, I've got my multimeter, I've got my controller, and as you can see the controller is not plugged into the actual track. This is the bus wire that we installed in the last video. So what I need to do before I plug this in is I need to check that I don't have any shorts. If you watched the last video, you see I tested it, but I didn't show you close enough the actual multimeter in test mode and how it all worked. So I just thought I would give you a bit more focus on that. So to test for shorts and continuity, which we need both, so in some circumstances, continuity, which is what we mean by a connected, a proper connection, we need that in some instances, in other instances we don't. So I'm just going to show you how to test it and how to make sure that you're doing what you're supposed to do. Again, I'm using this cheap little meter, which does exactly what I need it to do. So I'll put it onto the continuity setting, which means that I get the 1 on the screen. And when I have a short or continuity, I get numbers. So as you can see, there is a clear difference between when there is and when there isn't a connection. So the first thing to do is to check that I have no continuity between my two connections here, and it's quite difficult to get into there. So what I do is I go to my track, and it doesn't matter which way around your probes are for this, and all you have to do is touch either, and as you can see we don't have continuity, which is good. That's what we want. The next test is to make sure that we've got continuity from our source. So again, we do have continuity there and we don't have continuity there. So that tells me that my outer rail is connected to that outer connection on the controller, and then the inner rail is not connected, so I don't have any shorts, but then when I change I do have continuity, and that's what we want. So that was just a little short video on checking for shorts and continuity. Both are very important. Both are only important when they're required, which does make it a bit more complicated. And now I can be confident to plug in my controller and that it's not going to cause me any problems. Just like in the last video, I'm actually going to now create a short circuit fault so you can see what happens. So I'm just going to connect together a fault and just bridge over the track, and then again set the meter into the continuity setting. So again we've got our 1 up on the screen, and now when I test anywhere on the track I am going to get continuity, which means that I do have a fault. So as you can see, it's very decisive that there is a fault, and I can now go to here and also see that there's a fault. So we'll just break that just now. And as you can see, I've now got my controller turned on. So I'll turn it on, and on my screen you can see that there is no problems whatsoever. So the next thing I'm going to just check is that I have some voltage coming through onto the track. So again, with this being a cheap meter, as you can see it's showing 1 volt even though there's nothing connected to it. It's now settled. That's some of the issues you get with cheaper meters. So now I'm just going to check what voltage is coming across my track, which should give me 15 volts, 15.5 volts. And that's what we would expect all the time on a DCC system. And as you can see, I'm set to volts AC, which means it's an AC current I'm measuring, If you were to test this on DC in the same range of the 20 volts, you might get something, but you won't get what you expect, and that is 0.4 volts, which is not enough to run anything on. And of course, that bit with it being DC is polarity, so as you can see, that is a DC voltage coming through of between minus 3.3 volts and minus 0.4 volts. And all I'm doing to get the minus is I'm just swapping round, so we know that in this instance the inner rail is red and the outer rail is black. And then we swap it round. The inner rail is red and the outer rail is black. What I'm going to do now is I'm just going to actually connect up the DC controller and just show you what happens to each of those rails on the DC. So as you can see now, I've changed my connector over to a chocolate block connector to the pins that come from the Hornby controller. Everything's now plugged in, but my controller is set to the middle position, which is off. So in this instance, we're on DC voltage, so we'll check on the track and we should have nothing. Okay, so we have no voltage either way around. So on this one, the DC is turned all the way down, and we will have a small voltage now, which we're getting 1.61 volts, which is much higher than the DCC controller was putting out in its sort of standby mode. So now, just to show you how this controller works, so the arrow is now pointing straight up, so it's about halfway. So we should now have a much larger voltage, which is 8 volts. And again, we'll go up to the full, which should now give us our 19 volts coming out. So, like with the DCC system, I'll change it to the volts AC, and then we'll just have a look and we'll see there is no volts AC. But with this controller, I will have volts AC from these terminals, so 15 volts AC. So now we can look at the way that DC controls. So we'll turn the knob all the way back down to nothing. So when you saw me put my probes on, we got the small voltage, but we get, with the red on the outside and the black on the inside, we get a minus reading. We swap them round and we'll get a plus reading. And that's exactly how DC works. Because if I leave the probes sitting there and then flip the switch to the other way around, and I'll put some voltage through it, you see we've now got minus. And all I've changed is the switch. And that is exactly how direction works on DC. So that was a little introduction into how to use a meter and the principles of the DCC versus the DC system. very complex to think they've called it DC and DCC. But DC refers to the current of direct current, and DCC is digital control rather than the actual current that it's using. Hope this has been useful as a little extra. Thanks for watching.